everyone, and welcome to our first lesson of Math 4. This is Mr. Porter speaking. I'm hoping to help you guys start off strong. So we're going to be talking about representing intervals, and you're probably thinking, what is an interval? An interval is usually just a set amount of time or a series of numbers, so on and so forth. You are familiar with an important example of intervals, which is how long a class is. The interval for first period is from 8:30 a.m. to 9:30 a.m., 9:30 a.m., and so on and so forth. A common usage of an interval in math tends to be a number line. And as you can see from this number line, where this represents right here, everything greater than 2, intervals do not have to be finite. They could be infinite. It can go on forever. Time-wise, for like scheduling and stuff, of course, we want to make things finite, unless it's a math class, right? You would like to be in math class forever, of course. So let's go over the 3 different ways I expect you guys to be able to at least interpret. I want you to be able to interpret what these 3 different representations are: inequalities, set notation, interval notation. You should be able to, by the end of this lesson, look at one of these and know how to read it. So we're talking about how to deal with finite first. So finite is just between 2 different numbers, right? Maybe all numbers between 1 and 3. I'm going to show you guys a general format for this. So as an inequality, typically we would use x, and it can be between any 2 numbers. I'm going to have a and b for all these examples, guys. A and b could be any number. This could be 2 and this could be 4. And you've seen this before, hopefully. You've seen this in plenty of math classes. It doesn't have to be a line underneath here, right? It can also be no line, but I'm just going to use lines for this. Now, that's what an inequality is. You've seen that before. A set notation is very similar to an inequality. There's a small few differences. It has squiggle brackets right here, and it has an x with a line right here. And what this really means is for all of x, where x is between a and b. So it's a bit more of a formal way of representing the same thing as an inequality. And I just want you guys to be comfortable with knowing what this looks like, and simply, if I show you an example, you're like, oh, I know what that means. Now, once again, both of these might feel like, I feel like I'm writing too much, there's a bit too much effort. Well, at some point, mathematicians decided to be lazy, and they thought, hey, do we even need these x's? Couldn't we just have an a and a b, our start and a finish? And the answer is yes. And they actually use brackets for this, where they would use these hard brackets to represent if it includes the a and the b. And they would use these soft round brackets for if it doesn't include the a and the b. So in this case, to represent these, because we're including a and b, we would have a hard bracket here and a hard bracket here. And that's interval notation. If anyone looked at this, they would know you're talking about from a to b. And so you might prefer that more because it might be simpler. Let's try infinite, guys. So infinite is very similar, except for it goes infinitely at least in one direction. So this is like x is greater than or equal to a. That means if I put a number here like 2, that means all numbers greater than or equal to 2, but it goes on forever. It can also go down forever too, right? Where x is less than that number. Now set notation also looks very similar to this, where it's the same thing for both of them, with the squiggle brackets and x and a line on the side. For all real numbers of x, for all x values, x is greater than or equal to a, so on and so forth. Now, for interval notation, we have to use something besides just a, right? A start and a finish. So I want you to think for a moment, how do we represent something going on forever in math? That's right, we use infinity. Now, here's the thing. If it's going on forever in a upwards direction, in a positive direction, you must put a plus sign in front of that infinity. It represents it's going upwards infinitely. Because think about it this way. You can count 1, 2, 3, 4, 5, 6 forever, right? But no matter how much you count, you'll never hit the number 0. Unless we start this off with negative infinity, where x is less than a, so a is the highest it can be, and it'll go in a negative direction. It'll go downwards. So please, this is a big mistake people tend to make when dealing with infinity signs. You should, in this case, use a positive or a minus sign to represent what direction it's going. This might seem like a bunch of mumbo jumbo because we're dealing with like a and b as representing numbers. So let's go ahead and give you guys 2 examples with number lines. We're going to do the left side first. So notice how this represents everything between -3 and 2. It's not including -3, but it is including 2. So as an inequality, we could say x is greater than -3, but less than or equal to 2. Notice how x is sandwiched between these two, because x represents all of this black line and that 2. For set notation, it's going to look exactly the same, right, except for with x and the squiggly lines. Now, finally, for interval notation, remember, we don't care about x anymore. We just care about the numbers. So we're just going to have -3 and 2. But notice the brackets are different. It's a soft bracket because it's an open circle for -3, and it's a hard bracket, or right here, because we include 2. This means we go from -3 to 2, but we also include 2. Now, let's take a look at an infinite example. Notice that this is everything less than or equal to 2. Everything is below 2, but we are including 2 itself. So in this case, we would just say x is less than or equal to 2. That's it. Nothing over here, because any number less than 2 could work for this. Same thing for set notation. We are going to simply have the same thing as before, just with the squiggly lines on the sides and x on the line right here, and that just means the exact same thing in a more formal way. For the set of x, it's the set notation. Finally, remember, this is the trickiest part here. For interval notation, we can't just say 2, right? That doesn't make any sense. If you just say 2, we think, oh, we're just talking about the number 2. So what we would do here is, because this goes downwards forever, we would start, because there's no starting point here, we would say it starts with negative infinity because it goes down forever. We do not include negative infinity, so it's a soft bracket. You can never reach infinity, right? It's not like Buzz Lightyear, infinity and beyond. It's just negative infinity. And we have 2 as a hard bracket. And that's it, guys, for representing intervals. If you have any questions, please email me or save it for class, and we'll talk about it then. Otherwise, have a great day. Bye.